Hey Algebra. Today we're working through lesson 2, which is describing a center of distribution. We're going to construct a dot plot from a data set, calculate the mean of the data set and the median of the data set. We're learn how to describe and measure the center, which is the mean and the median, and how the center is nearly the same for distributions that are symmetrical. And then we're going to just talk about observing and explaining the means and the medians and how they're different when distributions are skewed. We talked about skewed yesterday. So to begin, look at our classwork. In previous work with data distributions, you learned how to derive the mean and the median of data distribution, and that might have been a long time ago. You might not have learned it if you're new to our class, new to the school, so we'll go through it again, not to worry. But this lesson is going to build on your previous work with what the center was. Cool? So let's look at the following 3 sets of data. We're going to do one set of data at a time. Here we have students from River City High School randomly selected and asked, how many pets do you currently own? The results are recorded below. So these are just results. One person said none, 0, 0. This is just individual people and what they said, right? We're going to do stuff with that. Can we assume that all the students interpret the question, how many pets do you currently own, in the same way? Just a random question I'm asking. Like, what's their interpretation of the question? I mean, if I own a fish tank, right? It has a whole bunch of fish in there. Do you love my fish? I think they're great fish. That's better. You know, is that 1 pet or is that 4 pets? I mean, in my mind, I don't like fish, but that is 4 pets, but you really count 4 fish the same as a dog or a horse, etc. And then what's up with the 10? Like, really? And maybe that is fish, right? All right, let's look at data set 2. Data set 2, the length of the east hallway at River City High School. 20 students were selected to measure the length of the east hallway. 2 marks were made on the hallway's floor, one at the front of the hallway and one at the end of the hallway. Each student was given a meter stick and asked to use the meter stick to determine the length between the marks to the nearest tenth of a meter. The results are recorded below. Well, that's interesting. How do we go from 8.2 to 8.9? Why would the same hallway have different reported measures of length? Why so different, right? I don't know. That's a little crazy. What measures of length of the hallway do you think are the most accurate from the data set? Do you think the 8.2 is the most accurate? Do you think the 8.9 is most accurate? Or somewhere in the middle, right? Okay, let's look at the last one. Age of cars. 25 car owners were asked for the age of their cars in years. The results are recorded below. We go from, sorry, that was a yawn. We go from 0 years all the way up to 8 years. What number would you use to describe the typical age of cars in years by the car owners in the groups? Like, which one is typical? What's your opinion? What's my opinion? I don't know. Okay. So what are we going to do with these things? First of all, let's do a dot plot. Oops. Make a dot plot for each of the data sets. Use the following scales. So I'm going to make a dot plot. This is the number of pets, right? So for 0, I've got 4. For 1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Two, I've got 1, 2, 3, 4. Notice I'm trying to make these about even. If I made one really squished together and one really spread out far, if the dots weren't sort of evenly spaced, your data wouldn't look. You wouldn't be able to look at your data and see if it was mounded or skewed or anything. So try to make your dots somewhat evenly spaced. Let's see, 3, I've got 1, 2. 4, I've got just 1, 5, 2, 6, 2, 7, 1, 8, 1, 9, 1, 10, 1, and 12, 1. Phew, that's sort of interesting. Okay, so remember that. We're moving on. I hope you made one too. East hallway measurement in meters. I have 8.2. Oops, that's sort of messy, isn't it? 2 8.3s, 2 8.4s, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. Oh, those are bad. Um, 2 8/8s and 2 8/9s. Okay, that's a nicely distributed dot plot. Okay, remember that one. And then the age of cars. 0, 1, 2, 3, 4, 5, 6, 7. Oop, 1, 2, 3, 4. 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, not very evenly distributed. Calculate the mean number of pet owners. Let me move to the next page, hold on. Calculate the mean number of pets owned by the 30 students from River City High School. Calculate the median number of pets owned by the 30 students. Okay, let's review. What does mean mean? Mean is considered the average of the numbers, which is sort of like a central value. To calculate, you just add up all the numbers. And divide by the number of numbers you have. So I'm going to push pause and I'm going to add up all of these numbers. 1 plus 1 plus 1 plus 1 plus 1, etc. Well, we could do this by hand, can't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So right there I'm at 28. Plus 5 is 33. 38. Oh, now it's getting hairy. 38 plus 6. Ooh, 44. Plus 6 is 50. Plus 7 is 57. Plus 8 is 65. Plus 9 is 74. Plus 10 is 84. Plus 12 is 96. So I have 96 divided by, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15 times 2 is 30. So 96 divided by 30 is 3.2. 3.2 is the mean, okay? The median is different. So I'm going to change to blue, median. Let's figure out, what does median mean? We're going to calculate it down there. So the median is a little bit different. Okay, the median, you put the numbers in order. From smallest to greatest. And you find the middle. Okay, the middle number, or the average of the middle two numbers. We'll see what this one does. Okay, so let's do it. what I usually do is cross off. I'm trying to find the middle. I'm doing it a very tedious way. I'm going to cross off 2, cross off 2, cross off 2, 2, 2. I could do more than 2, couldn't I? Yeah. Trying to find the middle. It looks like the middle two numbers are 2 and 2. So that means I would average those. So 2 plus 2 over two numbers is 4 over 2, which is in fact 2, which is silly. We could have figured that out. But the median is 2. The mean is 3.2. The median is 2. All right, next question. What do you think is a typical number of pets for students from River City High School? Explain how you made your estimate. This is the thing with statistics. I told you this yesterday. It's a much more an opinionated math. So if you're going to give me an answer, you have to give me a reason, and it has to be written in some type of coherent sentence or bullet point or something. So what do you think the typical number of pets? If you look at your dot plot for pets, if you remember, it sort of looked like this. Okay, so 3.2 was more down here, 2 was here. Typical number, I mean, it's really your opinion. Do you think it's the mean or do you think it's the median? I'm going to go with the median, and I will tell you why. The median's less than the mean. Because more data was on the left side of the graph. So more data was on the left side of the graph, left side of the scale. That would be that tail that we talked about yesterday. Therefore, the mean value is what's called pulled up by the larger values. On the right. Okay, so that's why I think the median is more typical. It's less than the mean because there's more data on the left side of the graph, more data over here. Therefore, the mean, which was the bigger number, is being pulled up by those larger values. I said that backwards. I'm sorry. Let's see that one more time. I hope you're paying attention. I still think it's the median. The median was less than the mean because more data was on the left-hand side. More data is here on the left. Therefore, on the left side of the graph, therefore the mean is pulled up by the larger values. Okay, the mean was making things seem a little skewed to the right. There's actually more values over here where the 2 is versus the 3. Okay? So where I said right here, the left side of the graph, that is not called the tail. The tail was on the right side of the graph. This would be your tail. I'm sorry to confuse you. Let's try another one. All right, so we have our next set of data. Why do you think that different students got different results when they measured the same distance of the east hallway? I don't know, because they're being silly. They weren't paying attention. They didn't take the project seriously. Let's see, maybe the meter stick wasn't straight. They had to use the same meter stick one after another, lay it down, move it, measure again. Maybe they didn't go in a straight line. Not on a straight line. What else? I can't think of anything else. What is the mean length? Remember, mean is the average. Okay, I'm going to go ahead and add those together and divide. Hold on. Okay, added them all together and divided by 20 values and found that the mean, which is the average, is 8.57 meters. Now I'm going to go ahead and find the median, which is the middle number. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 8.6 and 8.5. I'm going to add those two together. 8.5 plus 8.6 over 2 gives me 8.55 meters. And they are almost the same. If you remember, our dot plot was very symmetrical, which would make sense for our mean and our median to be the same. A construction company will be installing a handrail along a wall from the beginning point to the ending point of the east hallway. The company asks you how long the handrail should be. What would you tell the company? I would go measure it myself, personally, but if they're asking me this question, I'm going to round that up and say about 8.6 meters long. Okay, because the mean and the median are almost equal, I think you have a pretty good idea that the people in the middle did a decent job. All right, next one, describe the distribution of the age in cars. If you remember this one, I'm going to go back and look. Yep, this one went like this. Okay, not symmetrical at all. So, not symmetrical. Symmetrical. It is definitely skewed to the left. That would be where our tail is. Most of the data is on the right. Long tail to the left. What is the mean age of the 25 cars? And what is the median? Okay, hold on a sec. So my mean is 5.84. My median is 7. So my median is going to be more to the right, and my mean is more in the middle. Sorry, let's do this 5.84. Okay, let's analyze our data now. So they're different. The mean is smaller. Sorry, the mean is smaller because if we look at the graph, we have a very small number, very small values. In the tail of the distribution. So with our graph on the number of pets, if you remember, we went like this and our tail was there. And I believe our median was to the left of our mean. Okay, because we had our tail over here. Well, now we have our tail over here, and our median is to the right, because all of these values pull this one up. What number would you use as an estimate of the typical age of car for the 25 car owners? I would definitely use the median. Okay, when data is skewed, the median is a better estimate. Better estimate when data is skewed. When data is the same, when your data is very symmetrical, when your data is symmetrical, your mean and your median should be very close to each other, and that would be your estimate that you would use. Right, our lesson summary. A dot plot provides graphical representation of data distribution, helping us visualize it. The mean and the median are the numerical summaries. Okay, they're important. When distribution is symmetrical, the mean and the median are equal. When distribution is not symmetrical, often described as skewed, the mean and the median are not the same. For symmetrical distributions, the mean is an appropriate choice for describing a typical value. For skewed data distributions, the median is a better description. Cool? That's it. You got your homework. Nice job.